Have you ever wondered what happens to bodies of water when an earthquake strikes? It's a question worth pondering. Earthquakes jolt our planet's crust, but their effects ripple far beyond land, stirring up our oceans, lakes, and rivers in quite dramatic ways. One of these effects is the displacement of water. Earthquakes can shift enormous volumes of water, triggering abrupt changes in water levels and even causing flooding as the displaced water rushes towards the shore. Then, there are the seismic sea waves known as tsunamis. These potent waves, birthed by powerful undersea quakes, can journey vast distances and wreak havoc on coastal regions with extensive flooding. Let's not forget the eddy currents, those swirling water movements that can occur during and after an earthquake, adding to the turmoil of water during flood events. Lastly, there's the undertow, the backwash of water that can become particularly forceful during a tsunami or flood. Now that we have an overview, let's delve deeper into each of these phenomena. Firstly, let's discuss how earthquakes displace large volumes of water. Imagine the Earth's crust as a giant jigsaw puzzle. When these pieces or tectonic plates shift during an earthquake, the water above can be pushed or pulled along with them. This movement can result in a significant displacement of water. Think of it as a bathtub full of water. If you suddenly move one end of the tub, the water will slosh around and potentially spill over the sides. Now, apply this concept on a much larger scale to our oceans and seas. During an earthquake, vast amounts of water can be displaced, causing sudden and dramatic changes in water levels. This can result in a phenomenon known as coastal or tsunami flooding, where the displaced water rushes inland. This sudden rush of water inland can wreak havoc on coastal communities, causing widespread damage and even loss of life. Next, we explore how earthquakes can give birth to tsunamis. You may have heard the term tsunami, but what does it really mean? Tsunamis are large, powerful waves generated by strong earthquakes that occur under the ocean floor. When the Earth's crust shifts and displaces the water above, it sets off a series of waves that radiate across the ocean. These aren't just your regular waves. Tsunamis can travel at high speeds, covering great distances. What makes them particularly dangerous is their potential to cause significant flooding when they reach coastal regions. Imagine a wall of water, often several meters high, rushing ashore with immense force. It's not just the initial impact that's destructive, but the ensuing flood can wipe out buildings, infrastructure, and tragically, lives. The power and reach of tsunamis make them one of the most devastating consequences of underwater earthquakes. Our third topic is the fascinating, yet potentially dangerous phenomenon of eddy currents. Eddy currents are circular water movements that form when the kinetic energy of moving water interacts with obstacles. This could be land masses or underwater structures disturbed during an earthquake. Imagine a river flowing smoothly until it hits a boulder. The water deviates, creating whirls and swirls. That's an eddy current in action. Now picture this on a grander scale during an earthquake. The sudden shift in tectonic plates disrupts vast bodies of water, giving rise to these currents. These eddy currents can contribute significantly to the chaotic movement of water during flooding events, creating unpredictable and potentially dangerous situations. They can alter the course of water flow, increase turbulence, and intensify the overall impact of flooding. While eddy currents may seem less destructive than tsunamis, they add to the overall chaos and danger during flooding. So it's essential to understand these hidden forces of nature as they play a crucial role in post-earthquake water dynamics. Lastly, we tackle the powerful and often underestimated force of undertow. The term undertow may sound familiar. It's a common term used to describe the backwash of water that occurs when waves break on the shore and then flow back towards the ocean. When we experience earthquakes or tsunamis, this seemingly normal occurrence can become a formidable force, making undertow particularly strong and dangerous due to the volume and force of the water involved. Now, the force of undertow isn't consistent. It varies based on factors such as the size of the waves, the slope of the beach or shoreline, and the volume of water moving back towards the ocean. Particularly in the aftermath of a tsunami or a flooding event, undertow can exert significant force, especially in areas where water is rapidly receding. But what makes undertow powerful? The answer lies in complex fluid dynamics And the interaction between water and the terrain. Imagine this. The waves break on the shore, pushing water up onto the beach. As this water flows back towards the ocean, it can form strong currents that pull objects and even people out to sea. These currents are often strongest in narrow channels or areas with steep underwater slopes, making them a potential hazard in the aftermath of earthquakes or tsunamis. It's important to remember that the behavior of water during and after earthquakes or tsunamis is unpredictable and can be highly dangerous. The force of undertow is no exception. It's a silent, invisible pull beneath the surface that can catch us off guard. The unpredictability and strength of undertow make it a serious hazard during these natural disasters. It's a force that's often overshadowed by the more visible destruction caused by earthquakes and tsunamis. But it's just as important to understand and respect, because knowledge, as they say, is our first line of defense. So we've learned how earthquakes can trigger a series of events in bodies of water that lead to flooding, tsunamis, eddy currents, and undertow. These processes are not only fascinating from a scientific perspective, but they're also crucial for us to understand in order to better protect ourselves during these dangerous situations. When Earth shakes, it can displace massive volumes of water, causing sudden, dramatic changes in water levels, and potentially leading to flooding. Under the ocean floor, these seismic activities can birth tsunamis, large and powerful waves that can travel across great distances and wreak havoc upon reaching the coast. In the midst of all this, we encounter eddy currents, circular water movements that add to the chaos. And let's not forget undertow, the backwash of water that can pull objects and people out to sea with its force. It's important to remember, these water behaviors are unpredictable and potentially deadly. Follow evacuation orders and take safety precautions seriously. Remember, understanding these phenomena can help us better prepare and protect ourselves when disaster strikes.